So if I'm looking at the Cartesian coordinate system, I'm starting to graph things like equations of lines, um, ordered pairs, and things like that. So now I'm going to be moving out of just looking at domain and range and to bigger, larger ideas. The Cartesian coordinate system has four quadrants. They run counterclockwise. The first number is related to that horizontal line. The second number is related to the vertical line. The location of anywhere on the graph can be described as an ordered pair because A is describing how far to move to the right or the left from 0, and B is describing how far to go up or down from 0. The equations of horizontal and vertical lines have a special feature that make them easy to recognize. If you have y equals a number, you might think that it's going to be a vertical line, but it's not. It's actually going to be a horizontal line. If you have an equation like x equals 2, that's going to be a vertical line at 2. So then the axes are described as y equals 0 for the x-axis and x equals 0 for the y-axis. So if I'm wanting to sketch the graph, this is where I know that x equals 2 is a vertical line and it's occurring at x equals 2 on the horizontal axis. Same thing with y equals 3. I'm going to go to the vertical axis and I'm going to draw a horizontal line across 3. Here, if I know that x is less than 2 and I know that y equals 3, I'm taking that graph of y equals 3 and I'm cutting off anything after x. So imagine just erasing this entire part of the line, and that's going to generate what we have there. In general, the equation of x equals a is going to create a line that's perpendicular to the x-axis, and the line y equals something is going to be perpendicular to the x-axis. This is just an idea of what does y equals 2x look like, y equals x, and y equals 1/2 x. So these are actual graphs that are generated from plotting the points of plugging something in for x and getting something out for y. The slope of the line you probably heard a lot in the past is represented by the letter m, and it's a measure of steepness. If the slope is positive, it looks like this figure over here on the left. If it's 0, it's going to be a flat line, and if it's going to be negative, it's going to be this line over here on the right. If I want to find the equation of a line, I have to first find a slope. That's the starting point. So I know that my slope is going to pass through the origin of 0, 0. And so it's going to be in the line of y equals something times x. So that something be in the slope. So if I plug in 2 and 3, if I plug in 2, I get out 3. So I'm going to plug 2 and 3 in to what I know it looks like, and I get my slope as 3/2. So the equation of my line is going to be 3/2 times x. Here I have something called slope-intercept, and it's going to be a straight line through 0, b, and it's going to be parallel to the line whose equation is y equals mx. The equation of the line y equals mx plus b, slope plus y-intercept, can be found from the graph that we have here of y equals m times x by moving it up or down by a certain number of units. So it's like you literally pick the graph up and you move it by whatever the value of b is. So this is this idea shown visually of picking up the graph and moving it. The graph is going to cross the y-axis at the point 0, b. So whatever's being added or subtracted is going to tell you what the y-intercept is going to be. The slope-intercept form of an equation is any equation given to you as a number times x plus or minus another number. And the value of the x point of intersection is going to be called the x-intercept. The x-intercept is not as easy to find. The y-intercept we can find from glancing at this type of equation. X is going to take a little more investigation. So say I'm given this line, y minus 3x equals -6, and I want to find these key components. Well, the first thing is I need to get it in the form of y equals a number times x plus or minus a number. So I just added 3x to both sides to make that happen. Once I've done that, the number in front of x is my slope, and the number that's being added or subtracted is my y-intercept. Easy peasy, not too bad. For the x-intercept, we plug in 0 for y, and then we solve for x, so we get 2, which means that my x-intercept is going to be 2. If I'm given a graph, I can plot 2 points and then connect the dots to form a line. This is not traditionally used as much because we don't have rulers and we don't stop and pull out graph paper, but you can make a rough sketch using this method. Every line has an equation that is either going to be in the form of y equals mx plus b or x equals a, where m is going to be the slope and b is the y-intercept. So we can express every single line using one of those two. Any equation that can go into those forms is called a linear equation. So given 2 points, I can find the slope between those 2 points using the formula y2 minus y1 over x2 minus x run. Or if I'm given the graph, I can just count my rise over my run. So let's look at an example. If I want to find the slope of these 2 points, my y is my second value in the parentheses. So that would be 1 and 4. I want to take the second value from the second parentheses and subtract the first value from the first parentheses. So that's where 4 minus 1 is coming from. And then 5 minus 3 is the same idea, but the first value. In part B, I'm going to do the exact same thing. Slope is really just going to be a measure of your ability to do arithmetic. Here's another example. Let's say I have these 2 points and I want to find the slope of the line and the equation of the line. I have my 2 points so I can find my slope. Once I have my slope, I know it's in the form of y equals mx plus b. Well, if I look at this, I know that the y-intercept is -4. So I know that I have something going on there with that -4. So I'm going to take that and I'm going to plug that into the form of 4 over 5x minus 4 because my x-intercept is -4. So I've moved it 4 to the left and I show that by adding 4 to the equation. I can have a system of linear equations, meaning I have more than one equation on a graph. So if I'm looking at this example with the soy burgers here, I can take this and get two functions out of this. So I've got two different functions happening. I've got the 3x plus 12y and the x plus 4y because I have different products and combinations working here. If I know that Mary paid $12 for the other order, then I can then fill in some of the information. If I graph the two lines right here at the bottom, the point of intersection is always the solution to a system. It's a really good idea to utilize GeoGebra.com or Desmos.com to familiarize yourself with using technology to do this, because the majority of the time we're going to show students with technology early on in the process until they can really grasp the idea of an intersection happening. Since the lines intersect at 2, 1, that means the soy burger is going to cost $2 and the fries are going to cost $1. If I want to solve in a different way than from graphing the intersection, I could do this with substitution, which has the following steps. So this is just one option. Graphing is always going to be the easiest, but we also want to address when we're not going to have access to technology. So let's apply those steps to this system. So I'm going to rewrite one of these by solving for y. It looks like the easiest one to solve for y is going to be at the top, just with dealing with negatives. So once I solve it for y, I plug it into, or I substitute it into the other equation. Once I do that, I'm going to use my arithmetic to solve for x. So I'm using my equation skills to solve for x. Once I have the value for x, I'm going to take that and plug that into the equation for y. And so this would actually be the solution to that system. The elimination method, on the other hand, can be slightly easier for some people. You're either going to fall into camp substitution or you're going to fall into camp elimination. Here are the steps for elimination. So this is the process we're going to follow. Elimination is typically used when you have two values that you can just eliminate by subtracting the two equations. That's not true here. So I'm going to have to multiply the first equation by 2 so that when I add the two equations, the 4y is going to cancel. So 6 plus 5 is 11, 10 plus 3 is 13, but when I add those y's, I don't get anything. So I wind up with x equals 13 over 11. Now I'm going to take that answer for x and plug it back into the equation to get my y value. Whether you're using substitution or elimination, you're still going to plug it back into the original equation. Geometrically, I can characterize the solution to the system with these kind of key theorems. I can then apply that to my examples. This is not typically an area that I would say you have to focus on. Most students are going to do this with technology, with substitution, or elimination. So this section is not super applicable to what you're going to do in your actual classroom, but it is good to just show your students that there's other ways to do things. So if I write both equations in slope-intercept form, that's going to give me the slopes of the two lines. I'm going to notice the slopes of those lines are pretty different. Because the slopes are different, that means they can't be parallel or perpendicular. So if they're not parallel, and even if they are perpendicular, they're going to intersect one time. So if they were going to be perpendicular, they would need to be opposite. So the opposite of 2/3 would be -3/2. So it's not perpendicular, but because it's not parallel, it intersects at one point. So that tells me there's one unique solution. However, if I do this problem and I write it out, I notice I have the same slope. If I have the same slope, my lines are going to be identical if the rest of the equation matches up. So because I'm subtracting 4 in both of these scenarios, it's the exact same equation, so it has an infinite number of solutions. If, on the other hand, it's just got the same slope but different equations, then those lines are going to be parallel and there's going to be no solution because the solution is the intersection of two lines. If two lines never intersect, it can't have an answer.